An obsolete fan creates a dangerous shortcut: search the old model number, find something with the same diameter, and call it a replacement. That can fail even when the new fan fits through the opening.
A defensible replacement needs a passport with 4 verified layers: aerodynamic duty, mechanical interfaces, electrical and control behavior, and the application environment. Until those layers close, you have a candidate, not a drop-in solution.
Start by reconstructing the incumbent, not by browsing a new catalog.
Record the complete model and revision, every readable nameplate field, clear photos from both sides, the dimensional drawing, connector and cable details, airflow direction, rotation, and the machine where it operates.
Add the failure symptom and service history, but keep diagnosis separate from selection.
A stopped fan may be the victim of a control, power, bearing, blockage, or system problem.
Next, rebuild the duty map. Ask for the required airflow and pressure at the real operating point, then add part load and worst resistance points where the system must still work.
Align pressure definition, air density, speed, test configuration, and complete assembly before comparing curves.
Maximum airflow at free delivery is not the requirement.
The candidate must cover the operating envelope in a stable region with the correct margin, not merely touch one catalog number.
Now test mechanical fit as a chain of interfaces. Nominal wheel diameter is only one link.
Check inlet geometry, inlet ring relationship, outlet or open wheel arrangement, bolt circle, hole pattern, overall depth, wheel position, rotation, installation orientation, cable exit, connector reach, guard clearances, lifting path, and the route for future removal. A fan can match the front view and still collide behind the panel or become impossible to service.
Electrical compatibility needs its own page.
Verify voltage range, frequency, phase, input current, protective device, grounding, insulation or protection requirements, motor topology, and every external component.
A PSC motor may depend on a specified run capacitor. An EC fan may contain power electronics and require a different protection and switching strategy. Similar plugs never authorize similar wiring. The exact machine diagram and qualified electrical procedure remain controlling. Then open the control passport.
Record connector keying, pinout, signal reference, command type, scaling, enable logic, speed or status feedback, alarm contacts, communication protocol, register map, address, baud settings, and the response to a lost command. Two fans may both advertise 0 to 10 volt or Modbus control yet interpret limits, feedback, faults, or failsafe behavior differently. Those differences can stop an otherwise healthy machine. The seventh check is the environment and compliance boundary. Capture ambient and airstream temperature, condensation, humidity, dust, grease, corrosion, chemicals, altitude, ingress needs, mounting orientation, acoustic limits, intended use, and every approval required by the final equipment or market. A certification mark on one label is not blanket coverage for another model, voltage, assembly, country, or application. Required evidence must be reviewed for the exact candidate and project. With the evidence assembled, build a cross-reference matrix. Give each field one of 3 states, matched with controlled evidence, open and requiring verification, or incompatible and requiring redesign.
Do not hide missing data inside a green equivalent row.
A historical drawing can show how dimensions are organized, but its numbers belong only to that example.
Photos show visible geometry, they do not establish tolerance, material, internal electronics, performance, or fit.
Only now should the supplier nominate a candidate and move to bench qualification. Test the complete candidate on a defined boundary and compare the required operating points, not a cropped maximum. Record speed, electrical input, control response, faults, and the agreed aerodynamic and acoustic outputs with identified methods and acceptance limits. Test screen footage can illustrate curve capture, but no visible table or curve should be treated as proof for an unrelated project.
Bench evidence still does not equal installed system evidence.
Run an equipment pilot under the site's approved safety and commissioning procedure. Verify physical installation, guards and clearances, airflow direction, operating points, current, speed command and feedback, alarms, loss of command behavior, vibration, sound, temperature, and interaction with filters, coils, ducts, dampers, and parallel fans.
If a mismatch appears, return it to the passport. Do not tune around it without controlled engineering review. Before production release, close the supply chain page. Define the approved revision, drawing and software or parameter set, incoming checks, performance sampling, acceptance limits, traceability, change notification, packaging, spares, and rollback plan. A successful sample reduces uncertainty. It does not guarantee that every production unit or future revision is identical. Procurement should release the replacement only when engineering evidence and production controls point to the same configuration. The final decision is conditional and simple. If all 4 passport layers match and staged validation passes, release the candidate for the defined application. If one interface can be changed safely, label it a retrofit with controlled redesign. If the duty, safety, or compliance gap cannot close, reject it. That is how you replace an obsolete fan without replacing evidence with hope. Reconstruct, compare, test, pilot, control, and release only for the application you actually verified.